Hello, hello. This video will be going over our Algebra 2 Semester 1 practice final. This will be the last piece of content that I upload for you guys to study for your final, so I hope you find it helpful. Looking at our number 1, this problem is from Unit 1. It says identify the 5 key points on the graph and explain the graph's behavior. Based on these observations, provide a detailed 1-3 sentence description of the graph below. So let's first remember the 5 key points. Those are going to be our maximum, minimum, our x-intercepts, our y-intercept, and of course our start/vertex. In this case, our graph does not have a clear start point, so when there's not a start point, we use our vertex instead. So we can go ahead and label that as our vertex. And now we need to figure out what those points are. My maximum, my graph has no highest point. As you see, it gets cut off, but there are no ending points. So this implies that there is no maximum, or else that we could say that the maximum is infinity. Our minimum, being our lowest point, is identifiable, and that's going to be our point here. And that point that's going to be -1, -4. Again, careful with the scale. Each box is not equal to 1. Going down -1, -4. So our minimum is going to be -1, comma, -4. Our x-intercepts are going to be where our line passes through our x-axis, that being at this point and this point, that being 1, comma 0, and -3, comma 0. Our y-intercept is going to be right here. That's where our line passes through our y-axis, and that's going to be at 0, -3. Our vertex, we're going to actually use the same point as our minimum. Our vertex is also the lowest point of our graph, so we're going to write -1, -4. As far as behavior, this tells us a lot of the key points where the graph is going through, but we need to describe the shape. So this is going to be a U-shaped graph, and the word we use to describe a U-shaped graph is a parabola. Parabola. Secondly, we want to say what kind of parabola it is. In this case, it is a parabola that is increasing, or in other words, we could say that this is a positive parabola. And the last thing that I want to say, it's sort of implied by what we're saying about our maximum, but if you want to be very thorough, you could say that this increases infinitely, that it has no maximum. That talks about its end behavior. And I'm done as far as filling out this portion, and then I'm going to go ahead and take this information and put it into sentence form. I'm not going to go over that in this video. If you guys need examples of what that might look like, I encourage you to go and look at the Describing Graphs worksheet uploaded onto Google Classroom. But as far as identifying the key points of behavior, this is what we're looking for. Next, we're going to go ahead and look at number 2, which is still Unit 1 content, and it says choose 2 of the 3 representations of the function, table, graph, equation, to justify the given summary statement. So the focus we want to look at for this question is the summary statement. We must understand what the summary statement is talking about so that we could use each of our justifications to relate back to it. In this case, our summary statement says the function has a domain of x greater than or equal to -2. So I'm going to take this information, I'm going to highlight it, circle it, underline it, however you want to identify what your summary statement is talking about. And you want to make sure that each of your justifications has this as part of its explanation. So the main focus is we're talking about our x values. Our domain has to do with x values, and it tells you as such right here. So I'm going to be looking at my x values for each of my representations. So looking at our table, we have our x values out here. So let's go and take a look at what's happening with those. At -3, I get an undefined output. When x is -2, I get 0. When x is -1, I get -1. When x is 0, I get -1.14. So there are several things that are going on, but the main thing is I want to look at my x values, and talk about the domain, which x values work, which x values don't. In this case, I notice that my x values start working, start giving valid output at -2. Before that, I get undefined values. The values that I plug in that are less than -2 do not give me valid outputs. And I look at the x values that are greater than -2, -1, 0, and presumably 1, 2, 3, 4, if the pattern continues. They do give me valid outputs. So the table shows that x equals -2 is the lowest output, excuse me, lowest input. Definitely want to be careful about your vocabulary there. Is the lowest input to give a defined, you could say defined, you could say valid, you could say real output. Furthermore, all x values greater than x equals -2 also give defined outputs. So that's what I've observed. And you'll notice I'm using the same information. I'm talking about x being -2, and I'm saying that all values greater than -2 also work, which is exactly mirroring what my summary statement is saying. Can these justifications be a little repetitive? Yeah, they can be, just because we're talking about the same thing. If anything, we're looking at the justification, the representation, and seeing how does this support my summary statement. So the information is going to be repeated a bit. What we're talking about in terms of the table, we're talking about values. As we look over to the graph, what we're going to look and see is that, once again, we're going to go ahead and look at our x values, and I'm looking, my graph actually starts on the x-axis at an x value. And the graph starts at the point -2, comma, 0. Again, I'm referencing my value here. And what happens from there? The graph starts at -2, 0, and decreases to the right. So I don't even really need to put the decreases part. If you want to say n goes to the right, that's totally valid. But the point of me saying that is that my x values start at -2 and my graph goes to the right, meaning that all my x values to the right of -2 in the positive direction are also valid, also do work for my graph. The implication being that my x values before -2 do not work. So this is all you need to write in order to relate the graph back to your summary statement and to make that justification. Now, our equation part is the hardest justification out of the three. I'll just fully admit that. And what you need to do is you need to think about the constraints of the operations that we have in our equation or in our function. In this case, we know that we cannot have a negative number inside of our square root. It will give us an undefined value. So if that's the case, then what we need to do is to figure out, okay, if my inside of my radical cannot be negative, then the lowest value it could be is 0. So let's go ahead and start there. The lowest, the square root part of the function can be is 0. And when does that happen? That happens at x equals to -2. And then what do I mean by that? How do I know that? I evaluate. Okay, I have x plus 2 under my radical. What plus 2 would give me 0? So when x equals -2, what happens is I have -2 plus 2, which would then give me square root of 0, which would then give me 0. So this is the lowest output my square root part can be. So that means that the lowest x value that works, the lowest x can be, is -2. That's because if I put anything less than -2, then excuse me, I'm scrolling way too far up. If x is less than -2, then the inside would be negative. If I put a -3, -4, -5, the inside my radical will be negative, and I'll get an undefined answer. But once again, I'm talking about negative something lower than -2 not working on my function, which of course relates back to my summary statement. So that is the expectations and what I'm looking for number 2. Okay, moving on to Unit 2, number 3. So this one is getting away from our analytical part of Unit 1, and Unit 2 is going to be a little bit more hands-on, a little bit more computational. So it says for the function, and we're given a function, we're supposed to find the x-intercept and find the coordinates of the vertex form given. So I'm given the standard form and the vertex form of an equation, but I'm told to find the x-intercepts, which means I need to find my third type of my third form of my equation, which is going to be factored form. So in order to find x-intercepts, I must factor my function. So the way I set up my factoring is going to go ahead and make my box, and this is going to be my first term in my first box, my last term in my last box, and I'm going to go ahead and take my 16 and try to figure out what times what gives me 16. That will also give me -10x. Remember, you must account for that negative. So 16 could be broken up to 1 and 16, 2 and 8, 4 and 4. And looking at my prospects, the one that immediately stands out is 2 and 8, because 2 and 8 would add up to be 10. However, I want it to be a -10, so I'm going to go ahead and try making both of these negative. When that happens, -2 times -8 still does give me +16. So this combination that works. -2 plus -8 will give me -10. So I will treat this as -2x minus 8x. That being x and -2, x and -8. And my parentheses are going to be x minus 2, x minus 8. So we're done factoring, but I still need to find the x-intercept. The way that we do that is by setting our factored form equal to 0 and testing when does this equal 0 and when does this equal 0. Of course, x minus 2, when does that give me 0? Of course, that's when x equals 2. 2 minus 2 equals 0. Similarly, when x equals 8, 8 minus 8 gives me 0. So I have my two x-intercepts here. That being 2, 0, and 8, 0. For part B, I don't need to do any calculations. I'm not asking you to do any calculations here. What I do need you to do is recognize that when I give you vertex form, you know how to find the vertex. That being my vertex is always my h, comma, k value. And remembering the form of our vertex form, that's going to be a x minus h squared plus k. So my h value is going to be here, and my k value is going to be here. But you must remember, our h values, we always need to do the opposite. So if I have a -5 here, my h value in my vertex is going to be +5. As far as my k value, that's going to be -9. You just pull that straight out, and we have our 3 points for number 3. All we need to do from there is use the points from from parts A and B to graph the function. So go my two x-intercepts, that's going to be 2, and that's going to be 8. And I'm going to be looking at my vertex, that's going to be 5, -9. That's a 4. So that's plot properly. And from there, I need to go ahead and make my graph. I'm going to connect all my points, make sure that it's U-shaped. Don't want any sharp V's. That's not going to be a parabola, and we need a parabola for a quadratic function. And that's going to be it for number 3. Looking at number 4, it says use the graph below to write an equation of the parabola in vertex form. So I'm given a graph this time, and now I need the equation. So in this case, I'm going to start by looking at and identifying what my vertex is because I'm given vertex form. So let's look at that's going to be 5 and -4. So my vertex is going to be 5 and -4, which means my h and k are going to be 5 and -4. Now, as I start to write out the equation, remember our h rule. So I'm going to write this out as y is equal to a x. I have a positive 5, so I'm going to make sure inside my equation is going to be -5 squared plus k. If you want to write out your h as -5 here, that's fine, but just make sure whatever your h value is here and h value is in your equation, you must make sure that they are opposite sides. So don't switch it here and then switch it again here, making it positive. Make sure that whatever your vertex value is, that your h value in your equation, they are opposite sides. Okay? With that in mind, I also need a special point. I need to figure out what my A is, and I can't do that with 3 unknowns. Right now, I have a Y, A, and X value that are unknowns. Ooh, actually, that should be -4. Totally didn't replace my K. So as of right now, if I when I do it correctly, I have 3 unknowns. And I can't solve for A while I have 3 unknowns. So in this case, I'm going to look at what other points are on the graph. In this case, I'm going to look at my x-intercepts, those being 0, 0, and 10, 0. And again, when possible, I very much encourage you to use the point 0, comma 0, our origin point, because it makes the calculations much easier and everything cancels much easier. So what does that look like? Well, I'm going to use my x value and y value for my special point. I'm going to rewrite this as y. Ooh, excuse me, I'm not going to use y, because I now have a y value, which is 0 is equal to a 0 minus 5 squared minus 4. Give me 0 equal to a times -5 squared minus 4, which as I continue simplifying, this is going to give me 0 equal to a times 25 minus 4. So I'm done simplifying as far as I can go, but now the name of the game is to solve for a, which means I need to get a by itself. So the things keeping a from being by itself are my 25 and my -4. So those are the parts I need to look at to cancel. So the way I get rid of my -4, in order to cancel something, I have to do the opposite. So this can be +4. And what I do to one side, I must do to the other, which means this is going to be 4 is equal to a times 25. Again, that's times 25. A variable next to a parentheses is multiplication. In order to cancel, I must do the opposite, which means I will divide by 25, divide by 25. My a is going to be equal to 4 over 25. Now, as far as calculations are concerned, you are done. But in order to get this question correct, you must write your answer in its final equation form. You must fill in all missing variables. So we're going to start this in as y is equal to 4 over 25 times x minus 5 squared minus 4. And again, I don't need to worry about y and x. Those are parts of my vertex form. Those are going to stay as variables, but I need to make sure that my a, h, and k are all solved and accounted for. And this is your final answer for our number. Oh, what number is this now? That's going to be it for number 4. All right. looking at our last unit, Unit 3 is going to be going over some equality and some factoring. So let's see. Question 5 says, decide whether each of the following pairs of expressions are equivalent. They are equivalent. Show how you can be sure. If they are not, justify your reasoning completely. So, looking at A, the name of the game here is to simplify both sides. And then once they're both in the simplest form, we're going to try and see, are they equivalent? Are they equal? So let's look at our left expression first. It's going to be order of operations. I'm going to deal with my exponent first. And I've said it in class a bunch of times. I'm going to continue saying it. Our square does not apply to our x or to my 3. It applies to the whole thing, meaning that I'm going to rewrite this as 3x plus 3 times x plus 3. From there, you could either multiply and distribute the 3 inside our parentheses, or you could multiply our two parentheses. My preference is to just deal with my parentheses first. So I'm going to multiply my parentheses first, but I will let you know you can absolutely multiply your 3 into your first parentheses to start as well. So, you know what? This is a video. Let me show you both ways. So, if I were to just distribute my 3 first, again, I don't have 1, 3, so it only goes into one of my parentheses. That's going to be 3x plus 3. Excuse me. I need to actually multiply them. That's going to be 3 times x, which is 3x plus 9 times x plus 3. The second method I could do is actually multiplying out my two parentheses here first. If I do some side work, that's going to be x and 3, x and 3. Gives me x squared, 3x, 3x, and 9. And that would give me 3 times x squared plus 3x plus 3x gives me 6x plus 9. And as I continue down both these rows, I should get the same answer. So let's see. Doing my side work again, that's going to be 3x and 9, x and 3. That gives me 3x squared. That gives me 9x. That gives me 9x. That gives me 27. So if I simplify this side, that should give me 3x squared. 9x and 9x make 18x and plus 27. And as I multiply my 3 and distribute on this side, or this method, 3 times x squared is 3x squared, 3 times 6x is 18x, and 3 times 9 is 9. So those are two different methods of simplifying just our first expression. We're still just dealing with our first expression. So whatever route you went down, you should get 3x squared plus 18x plus 27 on this side. Now let's compare it to what's going on our right side. This one, there's no power to our parentheses, so we could start just by multiplying and distributing our 3x into the parentheses. 3x times x squared, we have 1x here, 2x is out here. So in total, that's going to give me 3x to the third. And doing 3x times 1, of course, gives me plus 3x. And of course, we just tack on the minus 9 at the end. From there, I actually have no more simplifications to do, so we are done. And looking at the two, though maybe at the beginning they look semi-similar, at their end result, we could say they are very different. So the answer is a very strong no, not equivalent. So I encourage you to write out why they are not equal. So you could say something along the lines of, well, each term is different. So you could definitely write about how my highest power x, one is squared, one is third. I have an 18x rather than a 3x, and I have a 27 rather than a negative 9. So definitely circling opponents, and if you could write a piece about what makes them different, identifying the key parts, or at least most a couple of the key parts, I would totally accept that. But that's what I'm looking for as far as number 5. And lastly, We come to our longest problem by far, number 6, where it says to multiply or divide the expressions below, leave your answers as simplified as possible. So I have my two fractions that have rational expressions in their numerator and denominators. The first thing you need to notice is I am dividing my fractions, which means we must implement the rule of keep, change, and flip. So I'm keeping my first fraction the same. I'm changing my division to multiplication, and I am flipping my second fraction. So this will be x squared minus 4 on top, and x squared minus 16 on the bottom. I'm going to cross this out because I'm no longer working with this original fraction. From there, it just becomes a factoring game. So I'm going to organize my work. It's going to be a very long problem. So the best way to set yourself up for success is by sectioning off and organizing your work. My first expression that I'm going to tackle is my first numerator, that being x squared minus x minus 20. This one I'm going to go ahead and factor. This gives me x squared. This gives me negative 20. And I'm trying to figure out how does negative 20 break up so that I get negative 1 when I add them together. In this case, the combination, as we think it out, is going to be negative 5 and 4. Negative 5 plus 4 gives me negative 1. So that's the component, or excuse me, that's the, I'll say component. That's the combination that works. So when I factor this, is going to be x and negative 5, x and 4. So this is the parentheses again. I'm going to get x minus 5, x minus 4. I'm going to go ahead and box my results so that's easy to identify later when I come back to it. Nextly, I'm going to go ahead and factor out my denominator here. So I'm going to go ahead and label this box 3x squared plus 6x, and then I'm going to try and figure out what do these two have in common. So I could quickly identify they definitely both have an x in common, but furthermore, 3 and 6 share a 3's multiplication fact. So that means that they also have a 3 in common. Once I establish what they have in common, I write out what I start with in order to determine what's left over. Whatever's left over is what I'm going to put on top. So 3x times what would give me x squared? What's the missing component? X. 3x times what would give me 6x? The missing component is 2. So when I factor this, this should give me 3x times x plus 2. And that is my fully factored form of my denominator here. So thirdly, I'm going to look at x squared minus 4. Again, x squared minus 4 is on the top now. I'm no longer considering my original fraction. When I did KCF, I flipped it. So x squared minus 4 is my second numerator. Of course, I don't have enough terms to factor, and they don't have anything in common. So what I'm going to do is I'm going to test 0 in the middle and see if I can make that work. So x squared plus 0x minus 4. And I'm going to try and break up negative 4 in such a way that it cancels and ends up being 0. So set up x squared and negative 4. And thankfully, negative 4 is a, or excuse me, 4 is a perfect square. Means 2 times 2 would give me 4. And since I have a negative 4, that means one of my 2's will be negative. So that means negative 2 plus 2 is going to give me 0. So I found a combination that works. That will add up to be my middle term. This will be negative 2x and 2x. Give me x and negative 2, x and 2. Give me the parentheses, x minus 2, x plus 2. And of course, I box that out. Very similarly, when I look at x squared minus 16, I'm going to employ my 0 method. I'm going to see how can I break up 16. And very quickly, hopefully, we notice that this is a perfect square. So I have x squared and negative 16. And 16 breaks up into 4 times 4. Meaning if I make one of them negative, that's going to be negative 4x. And 4x, those canceled to give me 0 in the middle. So I have the factors x minus 4, x plus 4 as my result. Now, now that I factored all four components, I am 80% of the way there. Now I just need to bring everything together, cancel, and then write out my final answer. So let's go and write this out. So I'm going to rewrite my fractions just in factored form. So it's going to be x minus 5. Let me do this down here because I'm going to need room. So I'm going to do x minus 5, x minus 4, all over 3x, x plus 2, times x minus 2, x plus 2, all over x minus 4, x plus 4. Meaning, I'm going to go ahead and cancel my x minus 4s, my x plus 2s, and my final result is going to be x minus 5, x minus 2, all over 3x times x plus 4. And that is my final answer for our final question, number 6. Happy studying, do your best, and make sure that you get plenty of rest the night before our final. So thank you very much for watching this video. Best of luck.